We are going to do breadth first traversal for binary trees. Last lesson we looked at depth first traversal. Now we're going to look at the breadth first traversal. So I'm going to show you what that looks like. For breadth first traversal, we always start at the root and then we go at each level of our tree and we're going to then output the nodes. So best way of doing this is to draw a curve that looks like this. And then going through the path of that curve, we've got letter M. We're going to read it from left to right. So F, T, B, H, P, and Z. Your turn now. Pause the video. Have a go at this one. So your answer should look like this. MET, CGPX, AD, FH, NR, UZ. Now we need to look at the algorithm because when we inspect this, you can see very well that you can just read the level out. But a computer can't just inspect. So we need to have an algorithm that tells the computer or program how to traverse through our tree. The first keyword we need to really look at is the word queue. So in the computer science, queue is a data structure that stores items in, first out order. So the first element is added and it is the first one to be removed. So think of it like a queue. If you are in a queue, then the first person in the line should get served first. And then anyone else joining the queue would need to go to the back of the queue. So we call that NQ. So when we need to have people at the back of the queue, we call it NQ. So we call it NQing. It means the nodes goes at the back. DQ means we are removing the front element, so the front node from our queue. So let's have a look at the algorithm itself. So it's just 4 steps, just simplified version. So in a breadth first search, the steps are always going to be, we first enqueue the root. Once we've enqueued the root, we then dequeue a node to process it. And then we enqueue its children. And we repeat these steps 1, 2, 3, 1, 2, 3 until the queue is empty. I'm now going to demonstrate how that will look like. So we're going to traverse through this binary tree using breadth first traversal. So we're going to start with an empty queue and queue root M. So we're going to put M in our queue. We're then going to look at M itself. So we're going to visit M. So when we get to M, we're going to dequeue M. So we're going to output it. And then we're going to enqueue its children. So its children. So its children are F and T. So what I've tried to do is I've color coded. So M is the one we're dequeuing. F and T are the one we're enqueuing. Now, if you think about our queue, we had M first. M is coming out, and we're putting F and T in the queue. So our queue will look like this. So it will have FT. And then we output M. The next on our queue is letter F. So we're now going to look at F and its children. So we look at F and we dequeue F. Now, once we dequeue the letter F, we then need to enqueue its children, B, H. Now, if you think about our queue, at the start we had FT. F has been dequeued, and we're putting B and H at the rear end. So we would have TBH. And then we output MF. Now, when we look at our queue, we need to look, who's the person, who's the next element? So we've got letter T. So step 3, we'll look at T and its children. So we now DQT, so T comes out of the Q. NQ, its children, P and Z. Now if you think about our Q, we've DQT, so we had BH, and we've NQ'd P and Z. So we would have in our Q, BH, PZ. And then we output MFT. So every time we DQ a node, we actually just kind of print it out, really. And then we'll look back and say, well, this is our Q, BHPZ. So step 4, we're going to DQ the letter B. So B is here, DQB. But B does not have any children. So there's nothing to NQ. So that means that on our Q, if we had BHPZ and with DQB, it means we have HPZ. So the output when we print this out would be MFTB. We'll look at our Q again, step number 5. We would have to DQ letter H. So H, DQH, H doesn't have any children, so what we have left in our Q is just PZ. And then we output H. Step 6, guess what the next letter is? So we've got letter P. So we DQP. Well, if P comes out, only Z is there. There is no children, so nothing to NQ. And that's what we output. Step number 7, we'll look at Z. We're going to DQ Z. Now our Q before only had Z in it, so it means that we now have an empty Q. We output Z. So finally, once that has finished, so now our Q is empty, we then look at our final breadth first traversal. So we would have MF T B H P Z. Your turn now. Pause the video and traverse through this binary tree. I'm going to show you the answer without talking so that you have enough time to mark your work and to think through our steps. Alright, so the final answer would be A, B, C, D, E, F. If you've liked the video, remember to click like. Thank you.